Combination. It's another vocabulary word. So we talked about permutation, now we're in a combination. And the difference between permutation and combination is that when it comes to combination, the order in which the objects are selected is not a consideration. Or in other words, order doesn't matter. In other words, again, order does not matter in grouping. So combination, really all we're taking a look at is putting things in groups. Not talking about specific order, this happens, this happens, this happens, but it's about grouping them all together. That's the most important part. So here, when it comes to a combination, this is what it looks like. And if you look at it, if you look through everything here, so the C, N, and R, so it means there are two different numbers here. So they're not going to be the same number, but different numbers. And then here we have n factorial for n minus r factorial. And then we have another r factorial. So the only thing that's different between the permutation and combination formula is just adding an r factorial on the bottom. That's it. Combination adds it, permutation doesn't. But n over n minus r factorial are the same on both the permutation and combination. Just add the r. Again, the problems can look like this too. I didn't write it down. Oh. So it can be the the NCR part. Now I'll write that here on the paper in a few minutes. And now with that, let's take a look at some objects here, because I want you to see that there's a difference between permutation and combination. And just to let you know that there's more for one than the other one every single time. So let's take a look at that on the paper over here. Okay, so before we do that, just know that when it comes to the combination, you can also see it this way. Just like we had the NPR or the NPN, it's the same thing. This means the exact same thing as what we just have over here on the screen, on your left side of the screen. So either one means the exact same thing. But looking at it, we're talking about objects E, F, G, and H. And when it comes to permutation, it matters the order that you put them in. For combination, it just doesn't matter because it's talking about just a group. So order matters, order doesn't matter. Okay, so permutation and combination. So we look at these objects and we're going to pair them up. We're going to talk about pairs here. All right, so with it, if we look at permutation, we can pair E and F together. We can pair E and G together. And we can pair E and H together. But when we compare those two, compare these together, order matters. So just because we have EF, that means we also have to have FE, because the order does matter there. Sorry, EF. If it's EG, that means we have to have GE. And if it's EH, we have to have HE, because order matters. So EF is one way, FE is another way, because the order matters when it comes to this. And that's not a 5, but a E. E. Okay. So let's deal with let's deal with, so we did all of our E's, so E. So I'm marking off all the stuff on my paper that I have. We did FE, we did GF, we did He. So we need to have things like FG. We need to have GH. Sorry, so FH. Sorry, got that one. So that means here GF is there. That means HF is there. And I think there's a couple others that we haven't done yet. Yep, the G's. So we have GH and HG. Those are two different ones. I think that's it. Let's see, 1, 2, 3, 4, 5. Yep. So that's all 12 of them. There's 12 here. So order mattered whenever we did those. Sorry, 12 there. So order mattered. Now when it comes to combination, it doesn't matter which way you put it in as long as you have the two letters together. So EF is the same thing as FE. EG is the same thing as GE. And EH is the same thing as HE. So if you think about it, it's really cutting everything in half, because if one way is there, the other way is automatically there no matter what. So combination is always going to be smaller than permutation, because it's always going to have less, well, it doesn't have to repeat itself. So when it comes to permutation, it's going to have to do one way and then it has to flip the other way. When it comes to combination, you have one way and that works both ways. Doesn't matter which way you do it, it means the exact same thing. So it means there's 6 here. So again, there are always more permutations and combinations. Always more permutations and combinations. Always. All right, and then let's go to our last example.